Okay, and let's continue on with the second part of our notes for day 2 of conics. This is our hyperbolas, so let's take a look at our second hyperbola that we have. We have got the y being positive, whereas the x is getting subtracted. So the fact that x is getting subtracted tells me my hyperbolas are going to be vertical. They open up and downwards. And again, same thing, we're going to look. The x value of the center is with the x, so that's a 0. The y value would be with the y, which is also 0. So I've got a center at 0, 0. Let me switch to a darker pen for you. 0, 0. The a value will always be under the positive variable. So in this case, my a value is going to be the square root of 9, so that's 3. The b value will always be under the term that is subtracted. So the square root of 5. C, we find, we have to do a little bit of math here, remember. So a squared, so that's 9, plus b squared is 5 equals c squared. 9 plus 5 is 14. That equals, the square root of 14 equals c. So c is the square root of 14. And if I need to have a value so I can plot it, which is helpful, square root of 5 is approximately 2.2. The square root of 14 is approximately 3.7. So let's go ahead and plot what we know. Our center is at 0, 0. A helps me find the distance to the vertex. So again, A helps with the vertex. And because it's opening up and down, it is a vertical hyperbola, I need to go up and down A units. So I'm going to go up 3 units and down 3 units from the center. So the coordinates here are 0, 3, and 0, negative 3. To find the focus, I have to use the c value. So I need to go up the square root of 14 units and down the square root of 14 units from the center. That's approximately 3.7. So about right there and about right there. So that's my focus and my focus, vertex, vertex. And I like to draw those in so we know where they are. And the coordinates of my foci are at 0 and then plus or minus the square root of 14. Okay, to get the equation of our asymptotes, again, this is just, we want you to know where to plug things in. It's a vertical one, so I'm going to have a above b to get the slope. So it's going to be y minus 0, so no need to write that, equals plus or minus a divided by b times x minus h. Well, h is 0, so there is my equation of the asymptotes. I'm not even going to worry about rationalizing this because this makes it difficult to graph, a square root of 5. I don't know what that looks like. So instead, I'm going to build this box. So coming back over here, if I went up and down to find my vertex and focus, I'm going to go right and left to find the sides of my rectangle. So 2.2 approximately to the right, 2.2 to the left, and now I'm going to build this rectangle. So it's going to come down, go through the vertex, up again, through this other point that was b units away, and there we go. Okay, so there's the rectangle I've built. Now remember, our asymptotes will go through the diagonal corners here, so I can just go ahead and draw this in. Dashed lines because they are asymptotes. And feel free to use a ruler to make it a bit more exact. But now that I've got asymptotes, I can go ahead and draw the hyperbola, the two sides. Staying close to the asymptote, come in, touch at the vertex, and then go back out close to the asymptote. And do the same thing for the opposite side. Come in, touch the vertex, and go back out next to your asymptotes. And we don't cross the asymptote. Those are there to guide us. Okay, let's turn over and try another one. Okay, let's try this one on the back before we get to more of a word problem and given a description. So let's see what we know here. The x term is positive, and the y term is getting squared. So that tells me I have a horizontal horizontal hyperbola. So that means they open right and left. So it's going to look like that. The center, it comes from the x value of the center is with the x. So it's at positive 2, negative 1. So positive 2, negative 1. We'll go ahead and put in our center right away. The a value is always under the positive term. So the square root of 9 is 3. And that tells me the distance to the vertices from here. So since it's horizontal, I'm going to have to go right and left by 3. 1, 2, 3. 1, 2, 3. So I've got vertices at negative 1, negative 1, and at 5, negative 1. Okay. To find my b value, it's under the term that's the variable that's been subtracted. So in this case, the square root of 25 is 5, so that's my b value. C value we have to solve for, so a squared plus b squared equals c squared. So 9 plus 25 equals c squared. 9 plus 25 is 34. And to get c, I have to take the square root of that. So square root of 34. And again, for graphing sake, I'm going to put the approximate value. Approximate value of 34 is 5.8. And to find where the foci are, I need to use my c value. So c is square root of 34, so that means I need to go plus square root of 34 to the right and then minus square root of 34 to the left. So this is going to be at 2 plus or minus square root of 34, comma, negative 1. So let's put both of these on the graph. That's approximately 5.8. So 1, 2, 3, 4, 5. There's 1. And 1, 2, 3. There's the other focus. And let's label our vertices also. So there they are. Now I need to use my b value to go the opposite way so I can create my box or rectangle. B value is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to create a rectangle using the vertices, and these 2 points that are b distance away. So you might want to remind yourself that distance is b, this distance is a. Just if that helps. And let's build our rectangle. And since we went off the graph, we're kind of estimating here where the edges are. Oops, that obviously was not very straight right there. Oh, you see what I did? I went to where the focus is. That is wrong. We go up where the vertex is. That looks better. Okay, so ignore this part over here. My mistake. Okay, we want to draw in our asymptotes now that go diagonally through the corners, which will force it to go through the center also. There we go. There are our asymptotes. And let's draw in our actual hyperbola. So it comes in close to the asymptotes, touches at the vertex, and goes back out. That's a nice wide hyperbola. Same thing here. Sorry, trying to ignore my mess over there. There we go. So that's what it should look like. And finally, the equation of the asymptote, y minus h. So it's always going to be what's in here, y plus 1 equals, it's horizontal, so I need the b on top. So plus or minus b divided by a times x minus h, or in other words, what's right here. Okay, so if I was trying to get the actual equation here, I would want to subtract 1 from both sides to get y by itself. So I have y equals plus or minus 5/3 times x minus 2 minus 1. And we could certainly do some algebra here to rearrange it and get x by itself and have 2 separate equations, but this is good. This tells me you know what you're doing. Okay, and let's watch the video for one last problem where we're taking words and trying to create the equation.